Hello and welcome to ELE3DEC, Digital Electronics and Controllers. I'm Dr. Robert Ross, and I thought I'd start off by giving you a little bit of background information about myself. I actually did my undergrad and PhD here. So I did double degree in electronic engineering and in computer science to give me a really good background on software design and in hardware design as well. And then I did my PhD in robotics, designing autonomous robots to search for explosives underneath people's cars. Something that's particularly useful around exam time, fortunately not at La Trobe though. My contact details and my room number and my email is there as well. So if you have any concerns at all or any questions, please get in contact and we'll see what we can do to rectify them. In terms of how this subject runs, the first 4 weeks or the first third of the subject is dedicated to digital electronics. So things like binary code decimal, binary and hexadecimal number systems, logic gates and Boolean algebra, and flip-flops and latches and things like that. We use all that knowledge and those concepts in the second section of the subject. So the last 2/3 of the subject are to do with microcontrollers, and microcontrollers are digital electronic devices. So we've got all sorts of concepts that we'll be looking at there, including things like interrupts and timers, analog and digital interfacing with these things, C coding, the actual architecture or what's inside these microcontrollers. And we'll end with a really nice lab, which is a microcontroller lab where you actually build your own laser tag system and actually design it and can shoot each other and zap each other and those sort of things. A really neat lab. To give you a bit of background, digital electronics is so widely used these days. We use it in virtually everything, and microcontrollers likewise. Our modern day cars have dozens and dozens of microcontrollers that control everything from our power steering systems to our fuel injection. We use them all the time. Even a lot of toasters these days have microcontrollers in them to precisely control what sort of time intervals that we're dealing with. Well, in terms of the teaching in ELE3DEC, we've got 6 main parts that we need you to engage with. The first part is these online lectures where you see me and I don't see you, or at least you don't think I see you, and we present all the concepts and all the theoretical knowledge that you need. And this will be interspersed with a whole lot of practical examples as well. Then we follow that up with online tutorials, and these are the problem solving part of the subject where we actually set a whole lot of problems, you have a go at trying to solve them, and I'll do worked examples and show you how you would go about solving them, best practice. There's also online forums, and these online forums give you a chance to address any concepts that you might not have fully understood. So you can post a question and other students or staff that are teaching this subject can post answers to them. Lots of times students might think, oh, I'm the only one with this question, no one else has this question. It's often not true. Lots of people have questions, and because they don't ask them, other people miss out as well on learning that particular knowledge. So please ask your questions and we'll endeavour as best as we can and as quickly as possible to answer those questions. We also have laboratories, and laboratories are a 3-hour chunk of time each week where you actually get to do hands-on design, programming, building circuits and all those particular things, putting all these concepts into action. So you'll be programming and building circuits and doing all those things. We follow that up with online quizzes, and the online quizzes, they're open book quizzes, so you can have all your lecture notes there, you can have any handwritten notes and things as well, and they're basically designed to keep you up to date and to give you a bit of knowledge in terms of what things you might be struggling with or what concepts you might not fully understand. So you only get 10 or 15 minutes to do the quiz, but they're open book, so you don't have to study for hours beforehand. If you're keeping on top of the material, they should be fairly straightforward to go through. And we also have 4 assignments throughout the semester. These assignments test some wide concepts that involve all the theoretical things, but also practical problem solving things in the subject as well, and get you to apply your knowledge to new problems. In terms of the overall assessment for the subject, these assignments and these quizzes are worth 10% each. We then have a huge chunk that's taken up by the laboratories because there's a big emphasis on you actually being able to solve real problems and being able to implement these things. And then finally, we have the exam, which is worth half of the subject, or 50%. Now, the learning outcomes for the subject, well, we have them listed here, and these learning outcomes really highlight a couple of things. That there's a fair bit of breadth in this subject in terms of digital electronics right through the microcontrollers, but also there's not just an emphasis on learning concepts and memorizing concepts, but actually being able to do things and program things and solve particular problems, apply these concepts to actually solve things. And that's a major cornerstone of this particular subject. So, talking about this particular subject, how do you actually succeed? Well, here's my top few tips. And the first one is actually watch these lecture videos before the labs and engage with the material before the labs. There's no point coming into the lab and coming in with an empty mind and trying to fill it then. The idea is before the lab, you actually engage with the material, learn the concepts you need for that lab, and then in the lab, you'll be able to go straight through and do a great job in terms of programming it and solving all the problems that you need to solve there. So engage with that material, both in class and outside of class. Also related to that, if you're having any trouble, have a chat to us early on. Put in your special consideration and things like that, but don't wait till week 11 or week 12. It's too late to solve a lot of problems then. Do it as soon as you can, and that enables us to develop solutions or tailor solutions to see a satisfactory outcome for everyone involved. Well, also experiment. Experiment with your microcontroller. The microcontroller that you use for this subject, you actually own, and you keep it after this subject. So the students who have historically done the best in the subject are ones that have tried new things and tried things not just what are in the labs, but also beyond what the labs do as well. The labs are kind of the minimum work you should be doing, not the maximum work you should be doing. And finally, keep on top of all the work. There's a fair bit of work. There's quizzes and assignments, and there's a whole lot of things you need to watch online, and there's these laboratories each week. But keep on top of it. Don't fall behind, because once you fall behind, it becomes quite difficult to catch up again. Well, that's all for the moment. Good luck in the subject, and also enjoy it. There's a whole lot of cool and fun labs, and gives you the skills to program and design microcontroller circuits and solve things with digital electronics. Hope you enjoyed it as much as I do.